This section is about solving application problems which result in quadratic equations. We're going to use the same techniques to solve this type of problem as we do to solve application problems resulting in linear equations. The only difference is that the equation to be solved is a quadratic equation. Let's review the procedure for solving an application problem. The first step is to read the problem. Reading the problem includes determining what the question is, how many answers are needed, do the answers need units, and are there restrictions on the answers, such as they must be positive or they must be integers. Reading the problem includes identifying keywords and key phrases in the problem. Those are numbers or words or phrases which represent mathematical operations like plus, minus, times, divides, or equals. Next, we determine how many variables we'll use to solve the problem. If there's only one unknown, then only one variable is needed. However, if there's more than one unknown, then more than one variable may or may not be used. Sometimes you can solve it with just one variable. Using one variable means that only one equation needs to be solved, but determining what that equation is might be complicated. After you determine how many variables you're going to use, write down what each variable means. This step will help in determining where the variable fits into the equation. It also helps at the end of the solution to determine what your answer represents. Using the variables and the key words that you identified, write the equation or the equations by translating the words in the sentences into mathematical expressions. Solve the equation or equations using one of the normal techniques: linear equation, quadratic equation, system of equations. Once you have the solutions to the equation, read the question again. See if the solutions to the equations answer that question. If they do, then state your answer using appropriate units. If they don't answer the question, then you may need to do a secondary calculation. Also remember that you may need to throw away some answers, such as if you get two answers, one positive and one negative, and you're looking for a length, negative cannot be used because you cannot have negative lengths. Now let's look at an example problem. In this example, a buyer wants to determine the lengths of the sides of a triangular shaped piece of property. He knows certain information about the relationships between the sides of the triangle. For instance, he knows that it's a right triangle. He knows that the longer leg is 20 meters longer than twice the length of the shorter leg. He also knows that the hypotenuse is 10 meters longer than the length of the longer leg. So step one is to read the problem. We must find three lengths, so the answer must have length units. Also, they must be positive numbers. Step two is to assign variables. This problem will only use one variable. Let's assign S to represent the length of the shorter leg in meters. Then, using the relationships between the sides of the triangle, the longer leg is going to be twice S plus 20, or 2S plus 20. Similarly, the hypotenuse is going to be 10 meters longer than the longer one, so it's 2S plus 20 plus 10, or 2S plus 30 is the length of the hypotenuse. Step 3 is to write the equation. Well, in order to write the equation, we have to work with the information available. We know this is a geometry problem because it talks about a triangle, And in geometry problems, you usually have additional formulas to help you with writing the equation. In this case, we have the Pythagorean theorem because we have a right triangle. Pythagorean theorem says that the square of one side plus the square of another side equals the square of the hypotenuse. If we substitute our expressions for the lengths of the sides into this formula, we'll get the following equation. Now let's solve this equation. First, we'll simplify both sides, and then we'll put it into standard form. Once we have the equation in standard form, we apply one of the solution techniques for solving a quadratic equation. We have 4 different techniques, some of which may not apply. But in this case, if we inspect the equation, we see that we can easily factor this equation. And so we'll choose that method for solution. If we factor the polynomial, we get s minus 50 times s plus 10. Set the factors equal to 0 and solve, and we get s equals 50 or s equals minus 10. These are the solutions to the equation. Let's take these solutions to the equation and state the answer to our question. Question was find the lengths of the sides of the triangle. If we examine the solutions, then we notice that one of our answers is negative. We can't use a negative value for a length. Therefore, we need to discard the answer s equals minus 10, which leaves us only with the answer s equals 50. Because these are lengths, then what that means is the length of the shorter side, s, is going to equal 50 meters. But the question said for 3 sides. We only have one side so far. We need to do some secondary calculation to get the other 2 answers. We need to calculate the other 2 lengths. The longer side is 20 meters longer than twice the shorter side. So twice 50 plus 20 is going to give us 120 meters for the longer leg. Similarly, the hypotenuse is 10 meters longer than the longer side. So 120 plus 10 or 130 meters. We can then compare our answers with the words of the problem, and we find that all the conditions are satisfied. Therefore, the lengths of the sides of the triangle are 50 meters, 100 meters, and 130 meters. 50 meters, 120 meters, and 130 meters. Let's look at another type of problem. In this type of problem, you'll be given a situation and an equation, and you will be expected to use the equation to answer the questions asked. A typical problem uses a physics equation describing the height of an object launched into the air and falling back to the earth. In this particular example, a projectile is shot from the ground, s equals 0, at 100 feet per second. 2 questions are asked. How many seconds after being shot will the projectile be at 50 feet, and when will it return to the ground? In the first question, we're looking for the time at which the projectile is at 50 feet height. In the equation, s represents height, and because we have a height of 50 feet, we're going to put 50 in place of the s. That gives us this equation. If we rearrange the equation to standard form, it looks like this. Once it's in standard form, we identify values for a, b, and c. Now, because we don't know whether this will we can't see that this will easily factor or apply any of the other techniques, let's go straight to the quadratic formula. Substitute the values for a, b, and c into the quadratic formula. And in this case, we're solving for the variable t, not for x, so it's t equals the formula. And I've already substituted the values in. You might want to write the quadratic formula before you begin substitution to make certain you get all the signs correct. But plugging these values in gives us this, and then we solve the equation. And I'm leaving out a lot of steps. It's just arithmetic you're going to do on your calculator most likely. When we do that, and then we round off to 2 decimal places, that's what the squiggly equal sign means, is approximately. We get the two values, 5.70 and 0.55. Two answers for a quadratic equation. Because both answers are acceptable, we can state the answer to the question. The question was, when will it be at the height of 50 feet? The projectile will be there at 0.55 seconds and 5.7 seconds after launching. Two answers make sense because if you think about the problem, something was launched upward from the ground and it went through the height 50 feet going up, then it fell back down to earth going through the height 50 feet a second time. That's why there are two answers, both of which are valid. Second question. It's very similar, but it says, when will the projectile return to the ground? Well, ground doesn't have a number, but in all the problems you'll see in this class, if it states ground level, you can assume that that value of height is the height 0. So we do have a numeric value. We have the value 0. We're going to put 0 in for S, and we'll get this equation. This case, it's already in standard form. It just happens that the polynomial is on the right side, not on the left side, but it's still standard form. And we should immediately notice that this is a very simple factoring problem. If we divide out the common factor of t, then the polynomial is factored. And that gives us this combination. Setting each of the factors equal to 0 and solving, we get the two answers, t equals 0 and t equals 6.25. So, ask yourself the question again, when does the projectile return to the ground? We can't use both answers. Both are valid mathematically, both are acceptable in terms of time units. However, the time t equals 0 is the time at which the projectile left the ground. The question asks, when will it return to the ground? And therefore, it returns to the ground at 6.25 seconds.